Alright, the exam 1 topic I'll be covering today is the topic of polymers. My name is Gant Meredith, and let's go ahead and get started. So if we look at polymers, what exactly is a polymer? Well, a polymer is a macromolecule. What does that mean? Well, let's dissect the word. So molecule meaning, a molecule. So something that has to do with elements, compounds, and bonds between them. And then we have macro, which means large or big. So that means that we're going to be dealing with large molecules. Let's look at polymer specifically. The word poly means many, and the word mer means pieces or parts. So a polymer is something that has many pieces or parts. And what are those pieces or parts called? Well, we call those monomers. Mono meaning one, and then mer meaning piece again. So monomers make up polymers. They're the building blocks. If we look over here at this polymer, this is a basic carbon chain that you can encounter in any organic chemistry class. If we were to write this out, it would be CH3, assuming all these functional groups coming off of the carbons were hydrogen. CH3, CH2, and how many of those do we have? We have 1, 2, 3, 4, 5, and then another CH3. This is a different way of noting our polymer, and it will actually help us identify what the monomers are. If we look at what's repeated, we see that CH2 is definitely repeated, as well as a CH3. So if we were to look at our monomers, we would have a CH2 monomer as well as a CH3, and you combine those to get this large carbon chain. We have several different types of polymers. Generically speaking, we'll look at two first. We have homopolymers. Homo means same, so these polymers are made of the same type of monomer. Then we also have copolymers, which are made up of at least two different types of monomers. For this course, there are going to be 6 common polymers that you will be responsible for. Let's take those one at a time. So if you look at polyethylene, you'll notice here that we have 2 carbons with 2 hydrogens each. So it looks like this. Now, how do you remember what this is called? Well, if you've taken organic chemistry, you will know that ethyl is 2 carbons, because it goes meth, eth, like this. This would be an ethyl. And so ethylene is just the polymer form of the ethyl compound. You'll see that the monomer, or the repeating unit, is again that CC bond. If we look at polyvinyl chloride, well, you'll know that the easy way to remember this one is that we have a chloride coming off of the carbon. So it's almost identical to polyethylene, but we have the chloride coming off of the carbon instead of a hydrogen. Now if we look at this one, polytetrafluoroethylene, well, we said that ethyl was 2 carbons, so we have those 2 carbons present. And then tetrafluoro, well, we know that tetra means 4, and fluoro refers to fluorine, so we're going to have 2 carbons with 4 fluorines in total, 2 fluorines coming off of each carbon. If we look at polypropylene, we know from organic chemistry that propyl is 3, so meth, eth, prop. This would be the organic chemistry notation for propyl. So propylene, we simply have the same thing as polyethylene, except now one of the hydrogens is replaced by a CH3 group or an ethyl group, and that's how we get the extra carbon to make the 3-carbon chain, which again is a propyl group. Now for polystyrene, this is a functional group that you learn in organic chemistry, where styrene has a benzene ring coming off of a carbon chain or a carbon compound, and that is how you remember this compound. Then the last one is a little complicated, polymethyl. So we said meth was 1, So you'll see that there is a methyl group coming off of not only this carbon, but this oxygen as well. And then methacrylate. This is a functional group known as crylate. This is not encountered in Organic Chemistry 1 or 2 at the University of Florida, but it is quite the mouthful to remember the whole name. So I would recommend just memorizing the acronym because we haven't learned enough organic chemistry, especially in this class, to know exactly what crylate is and how it functions in a carbon chain polymer. But again, these are the 6 common polymers you should be responsible for the exam, and you should be able to recognize the mer units or the repeating units that are present in each polymer. So now that we've discussed what polymers are, let's talk about how we can characterize them or how we can classify them. So the first way is by calculating the average molecular weight. Now, to do this, we can either do a number average or a weight average, and the equations are here on the right. For both equations, it is important to remember that we are finding the sum of the mean molecular weight of the size range I, notated here, multiplied by either the number or the weight of the repeat unit of the monomer that we have repeating to make the polymer chain. Now, the second way we can classify polymers in this course is by degree of polymerization, which is the average number of monomers, or the repeating units in the chain. And so we can calculate this by finding the number average molecular weight and then dividing it by the molecular weight of the repeat unit, and that will give us the average number of monomers in the chain. Now if we look at tacticity, this has to do with the orientation or the arrangement of the repeat units along a polymer chain. Now, the first type of classification would be isotactic, and we remember that iso means equal, so it means that all of the repeat units are on the same side, or all of the R units. So, if we had this, for example, just this little mer unit right here, we have meth eth prop. It is going to be a propyl carbon chain, and on this side we will have these R units coming off of the carbons. Now because these are all on the same side, this would be isotactic. Now syndiotactic would be alternating sides, so as you can see here, the R's are on alternating sides of the carbon, which would make them syndiotactic. And then atactic would be random sides. So you could have one R coming off here at the top, one coming off here at the top, and the next one could be at the bottom, and it's just all over the place. That would be an atactic polymer chain. Now, we also have compounds called copolymers. Now, co means two things present, and then polymer, of course, is a repeat unit of, or a repeated set of monomers that we combine. So if we look at the first type of copolymer, we have a random one. So let's say that the black polymers are notated as polymer A, and the red polymers are polymer B. Now, random, you can see that there is no pattern between the A polymer and the B polymer and the way they're aligned. You can't discern a pattern between A and B alternating. Speaking of alternating, let's look at the alternating type of copolymer. This is where you literally have A alternating with B, then back to A, then back to B, so on and so forth, until you reach the end of your polymer chain. Now, block is somewhat similar to alternating. You, instead of having directly transitioning from A to B, we will have blocks of A transitioning to blocks of B, transitioning to blocks of A, back and forth. The important thing to remember is that the blocks do not have to be the same size. You can see here we have 1, 2, 3, 4, 5, 6 black next to 5 red. So they do not need to be the same size, just need to be present in blocks. And then the last type of copolymer is a graft. So we will have a base for the graft, notated here by the red polymers, and then we will have the black polymers that are grafting off of the base polymer, the red one. Now, when we look at especially carbon chains, this is a very important topic in organic chemistry, we have things known as isomers. Now, isomers are different ways to write or represent the compound with the same molecular formula. Because if we were to count the number of carbons and hydrogens present in both of these examples down here, we would see that they have the same number of carbons and the same number of hydrogens. So how do we identify them differently? Well, there are different types of isomers. So the first kind is a stereoisomer, and this is an isomer that rotates about a stereocenter. And what is a stereocenter? Well, it's an sp3 hybridized carbon. What does sp3 mean? Well, it means that there is one s orbital and three p orbitals. Simply that there are 4 electron groups surrounding the carbon. So if we were to have, imagine we had 4 different functional groups coming off of this carbon, this would be sp3 hybridized, and it could also be a stereo center where a stereoisomer occurs. Another important thing to note with stereoisomers and stereocenters is that they have to be around single bonds, and that's because single bonds can rotate while double bonds cannot. Double bonds are linear and they cannot rotate in three-dimensional space. Now, the other type of isomer is a geometric isomer, and this has to do with the location of the groups relative to an alkene, or a double bond for the sake of this example. Now on the left, we see that the CH3 or the methyl group and the hydrogen are on the same side of the double bond, which means that this is a cis isomer, because cis means same. If we look over here, we see that the CH3 or the methyl group is on the opposite side of the alkene or the double bond as the hydrogen, so we call this one trans, because trans means opposite or across. So now that we have covered that, let's talk about polymers when they come into contact with heat. This should be the last element on the exam for polymers that we'll need to cover to be sure that we are all ready to go. So if we look at the compound on the left, this is known as a thermoplastic. And if you think about a plastic, they're normally pretty flexible, and if you put a plastic in the microwave long enough, it will start to alter its form and will start to warp. So it will become softer. So thermoplastics are flexible, they're linear, they soften when heated, and they're also reversible. So what I mean by that is, once you heat up a thermoplastic, it can still go back to its previous form. And a thermoplastic is right here on the left. Now on the right we have what is a thermoset, and as you'll see, the thermoset is much more organized than the thermoplastic. Because it's more organized, the structure is rigid, it is permanent, and as you can see, it has a network structure going on here. Now when I say permanent, what I mean is once you heat a thermoset, it's done. It's a one and done kind of deal, and you can no longer go back to its previous state. That is all we have for polymers, and I feel that you will be ready for the exam material if you were asked about polymers on exam 1.